Chapter 18, the periodic table of elements. The first thing we need to cover is the parts of an atom. And we have talked about these in the past. We are going to go into much more detail this chapter. So here is my simple model of an atom. An atom, by definition, is the smallest piece of matter that still retains the property of that element, which means if you divide an atom, you no longer have an atom. The smallest piece of matter that still retains the property of the element. Again, an atom can be divided. We'll see here the pieces that make up the atom, but once you divide the atom, it's no longer representative of that element. One piece of the atom is known as the electron. They are very, very small, very fast, and they are located in the electron cloud. This chapter will also give us several details about the electron cloud. Right now we're just going to note that it is the region around the nucleus where we find the electrons. The nucleus is the positively charged center of the atom that is made up of two particles, the protons and the neutrons. So there are the main parts of the atom. We will give more details down below. So major parts of the atom, things to know. Now we are going to look at one piece of one little square of the periodic table, which of course represents one element. In this case, I chose phosphorus. We start with the capital P, which is known as the symbol for that element. So the symbol is the letter or letters. Some of them have two letters, a capital and then a lowercase, that represent an element. And the name is usually found below the symbol. However, some periodic tables might not have the name written out. They will, however, always have the symbol in each square. The name is specific to the atom depending on the number of protons. There's the name. That's how each atom gets its name, by the number of protons, which lead us into the atomic number. The atomic number is describing the number of protons in an atom. atomic number is found usually in the upper right-hand corner of each square in the periodic table, but it can be in the left-hand corner as well. The atomic number for phosphorus is 15, which tells us that phosphorus has 15 protons. The big important piece of information that we need to always remember about atomic number is the atomic number determines the type of atom. For example, if we have a nucleus that has 6 protons in it, it is the nucleus of a carbon atom. If we have an atom that has 20 protons, it is a calcium atom. And so we always need to refer to the periodic table to find out how many protons belong in each different element. So the atomic number is in each box of the periodic table. Protons. Atomic number is all about protons. So protons are positively charged subatomic particles, which just means they make up atoms. Again, positively charged. They have a positive charge. They are found in the nucleus. And they have a mass of 1 atomic mass unit. Oops. Which we abbreviate as AMU for atomic mass unit. Protons we need to associate with atomic number. Atomic number, protons, atomic number. The other particle in the nucleus is the neutron. So the neutron has no charge, but it is also a subatomic particle found in the nucleus, and also has a mass of 1 AMU, atomic mass unit. No charge, so again, you could say it is neutral. It is found in the nucleus, and it has an atomic mass of 1. The neutron comes into play when we discuss mass number. The mass number is the number of protons plus the number of neutrons in an atom. So we could think of it as protons plus neutrons equals the mass number. One thing to note about mass number is this will not be on the periodic table. the number that you people try to make into the mass number is actually the average atomic mass, which we have over here. Average atomic mass and mass number are not the same thing. The mass number is not on the periodic table. So we can determine the number of neutrons in an atom. If we know the mass number, we can figure out how many protons it has by finding its atomic number, which is on the periodic table. We can subtract. So, for example, if we have an atom of carbon-14, which is a version of carbon, it's the less common version, we know that carbon-14 has 6 protons because it has an atomic number of 6, which you can find out by looking on the periodic table. The 14 right here is the mass number, which means we can subtract to find out that carbon-14 has 6 protons and 8 neutrons, because together there are 14. So we subtract to find out how many neutrons there are. Another example would be if we had an atom of sulfur that had a mass number of 13. By looking at the periodic table, we know that sulfur, every single sulfur, has 16 protons, which means it also has 16 neutrons, because 32 minus 16 is 16. So that's another example of how we can use the atomic number and the mass number to figure out the number of neutrons. Our third subatomic particle is the electron. Electrons have a negative charge. They're negatively charged. They are not found in the nucleus. They are found in the electron cloud, which we will describe more about the electron cloud later. And they have a mass of 0 AMU. They do have a mass, but it is very, very, very small. And so we don't really need to worry about it at this time because it's so small, it is insignificant. We get to pretend like it has a mass of 0. The number of electrons will be equal to the number of protons because each atom is electrically neutral, which means it has no charge. So the number of electrons will be equal to the number of protons. Positiveness is equal to the negativeness in every atom. All right, let's talk isotopes. Isotopes are variations of an atom. An isotope is atoms with the same number of protons but different numbers of neutrons. Changing the neutrons does not change the identity of the atom. That would be protons. If we change the number of protons, we would have a different kind of atom. But neutrons, they have no charge. They their numbers can change. A common example is carbon 12 and carbon 14. They are isotopes of each other. Carbon 12, of course, has 6 protons and 6 neutrons because the atomic number is 6, therefore 12 minus 6 is 6. So 6 protons, 6 neutrons. Carbon 14, just like we did over in that example. Over here, right here, there it is, carbon 14. 6 protons, again, it's still a carbon atom. Where are we going? Here we are. And 8 neutrons. Different isotopes do have different chemical properties. Carbon 12 is one of the most common atoms that we have on Earth. It's what most of our bodies are made out of, and anything else organic is made out of carbon 12. Carbon 14, however, is in fact radioactive, which means it will decay, it will break down over time. Atom that breaks down over time. And we talk more about radioactivity later on. Right now, we just know that they're not stable. They can emit a type of radiation, alpha particle, a beta particle, or a gamma ray. But isotopes have the same number of protons and different numbers of neutrons. Average atomic mass, we're going to put our definition in here, but we have a whole separate lesson that is devoted to average atomic mass. So we'll talk more about that later. Our definition for today is the weighted average mass of a mixture of isotopes. The weighted average mass of a mixture of isotopes. So this takes into account how much of each isotope exists. It's not just a plain average. We have to figure out which one is the most common and things like that. Again, we talk average atomic mass in a whole separate lesson, so we'll come back to that one and add more later. Okay. The box up here that's all about atoms, we are going to do a couple examples of what you will be doing on your homework. Your homework for this lesson gives you an isotope. So one might be nitrogen 14. And you then are asked for the number of protons, the atomic number, electrons, neutrons, and mass number. So nitrogen 14, to check out its atomic number, which is also the number of protons, we need to look at a periodic table. Nitrogen is number 7. So its atomic number is 7, which is also the number of protons. And again, protons and electrons are equal to each other, so that is a 7 as well. To find the number of neutrons, we need to look at its mass number. Its mass number is 14, and then to find neutrons, we subtract 14 minus 7, which is also 7. So that is an example. Let's do one more, or maybe two. Maybe we'll do two more. Let's look at sodium. And we have to have a specific isotope of sodium. So let's do sodium 24. To find the atomic number, we find sodium on the periodic table. We see that sodium, which symbol is Na, is 11 on the periodic table. The atomic number, the protons, and the electrons are all equal. The mass number is 24 because it is given. And to find the number of neutrons, we will subtract 24 minus 11, which is 13. One more example. This time we're going to make it a little more difficult. We are going to start with the atomic number. So let's do number 18 and a mass number of 40. We can first figure out protons and electrons because they are equal. So 18 and 18. And then we have to think neutrons. To find neutrons, I need to take 40 minus 18, which is 22. Usually the number of protons is pretty close to the number of neutrons. As the atom gets larger, the numbers can get farther apart, but for the smaller numbers, they are going to be very close to each other. The last piece of information we need is what type of atom is this? Well, the type is always determined by the atomic number. So on my periodic table, I look up number 18, which is argon. So when you do this homework assignment, you are going to want to be able to look at a periodic table. So you can download an app. There's a really good free periodic table app that you can download, or you can save a picture of a periodic table from the internet. They're all the same. Some of them are more user-friendly than others, but they have the same information on them. So definitely find a periodic table for yourself when you do this homework from this section. Find a periodic table. So there is our introduction to the atom and the periodic table.